All right, here we go, my beautiful geometry honors friends. I know you want these videos to be done, but so do I. But we got one more thing. All right, now, something I purposely didn't talk about it yet, but if you go back to every problem we've already done, and I'll try to keep this short and sweet like me, but these two are the same size and shape. These are the same size and shape. Same size and shape. So every picture you've made except for one was the same size and shape. The only time we didn't get that was our dilation. Those are not the same size. Still the same shape though. So something special. The word is isometry. So that's a transformation. It preserves length, angle, measure, and area. And so the key takeaway here is with an isometry. Now I think I'm going to try to find another color. The image is congruent to the pre-image. I would actually stop and just memorize that really quick. So isometry is a transformation where the image is congruent to the pre-image. So those are all the key words you can say in one sentence there. So the isometry is a transformation where the image is congruent to the pre-image. In some places like Khan Academy or Delta Math, you might see the words rigid transformation, and that's just basically it cannot change in size or shape. Okay, you can change its location. So, and then just to wrap this little nugget up, so your translations, reflections, rotations are isometries, and then the dilations are not isometries. So, and in this chapter 3 is all about congruent triangles, and so we're going to focus, so all the things in this chapter would be created with translations, reflections, rotations. All right, so now to finish up today, we're going to talk more about congruence, and this is really what's going to carry us through the whole rest of this chapter here. Okay, so for two triangles to be congruent, all pairs of corresponding sides and angles are congruent. Now, it's not mandatory to draw a picture, but I think it's a great idea. So let's draw a triangle, and here's a little secret. Actually, you can hold your pen. That looks nice. Maybe I'll make it a little bit not perfect there. Now, go ahead and duplicate it because we are talking about congruent. Look at that. We just saved a few seconds. How beautiful is that? We'll stay purple. So there's the DOG, and there is the CAT. So what we know right now, if we have congruent triangles, then all of the corresponding sides are congruent. So this side, segment DO, congruent to segment CA. And here's a little secret. Even without the picture, you can tell that. And so the OG, original gangsta, is congruent to the AT. And so you can see right there, OG, AT. And then the DG is congruent to the CT. DG, CT. And then guess what? The angles, the D lines up to the C. So angle D is congruent to angle C. I'm running out of colors. Let's see. I guess we could go, nope, this one. Angle O, angle A. And let's make a big star. Angle G, angle T. All right, so there we have it. And that's going to be used in many, many lessons. Now the polygons, not as much, but because chapter 3 is all about triangles, and then chapter 4 will have 5 will have quadrilaterals. But it works the same here. Let's do this. Go ahead and say sides and angles, duplicate it. We don't need to write it again. All right. I don't know if I guess we could do this. Maybe to be fast, we'll do Foxy Fill without drawing it, and we'll just grab a bunch of different colors. So let's see. So FO lines up to PH, and if you want to fast forward this part of the video, that's okay. The XY lines up to the IL. Yeah, that's good for Illinois. The FY lines up to the PL, and the OX lines up to the high. And we could do the same thing with the angles. Maybe I don't need to switch colors every time. How about that? So how about F lines up to P, and O lines up to, oops, no angle symbol, 10 burpee penalty. Angle X lines up to angle I, and angle Y lines up to angle L. All right, good times. All right, home stretch. I hope you're still awake. We got to finish this up. Okay, so here we go. This is going to be used for the next 3 chapters. The reflexive property. It's not going to make much sense now, but it will become important for us in lesson 3.2 and beyond. So right now it doesn't make sense. Of course, any segment or angle is congruent to itself. It's the same size and shape as itself. You're congruent to yourself. But you'll find out tomorrow why we're going to do this. But so all we're going to do right now is look at this first picture. I might call it a kite, but that's foreshadowing chapter 5, so we don't need to call it a kite. But what you might see here is that segment KT is congruent to KT. So the reason that's actually important is there's 2 different triangles in that picture that have KT as a side. So that'll be something that we do in future lessons. And we're just going to call it REF prop, reflexive property. So no if-then statements, nothing else, just ref prop. What you're going to see on the next example, they made one triangle really dark for us. That was nice of them. And then there's another triangle right there that they kept light. But the whole thing that's happening here is both of those 2 triangles have angle Q. So angle Q is congruent to angle Q by the reflexive property. All right. I know you want this to be done. Let's wrap it up. So I'm going to suggest pause the video and see if you can fill in these 3 things. You are going to have to pay close attention. When you go to make the triangle statement, pay close attention to the tick marks. Okay, you can't just write the letters in any order. So that's going to be a big deal for multiple chapters, 3 to 4 chapters of this course, even more than that probably, is lining up those letters. So I'm going to say pause the video and then come back to it when you want to check your answers. All right, so our first one says triangle ERC. So when I go to make my statement, which one lines up to E? That's going to be the T. And then so I'm looking. So if I go E to R to C, right? There's lots of ways you could talk about it, but I'm gonna go right angle, then slash E, then dot. And so I need to do the same thing. I'll switch colors. So I'm gonna go right angle, then slash E over to dot. So that's gonna be TCR. TCR is the only answer for that. And surprise, surprise, why is the same segment congruent to itself? Because that's the reflexive property. There you go, now you see it. All right, if E is a midpoint of TP, that means we have an extra set of congruent segments. And now let's grab a highlighter, I guess. Triangle SPE. SPE. So follow those tick marks and then try to make the next one. So SPE is going to line up to RTE. I don't know how the E got chopped off. That must have been very painful. Uh-oh. So that is, what do we say? RTE. All right. There we go. And the triangle bow is congruent to another triangle. And this one messes with me because I just want to say bow tie. But I can't just say bow tie because that doesn't make sense. All right. So look at your tick marks, B to O to W. All right, look at this. So we had a double, then a single, then a blank angle. So there's the bow. Well, I don't even know anymore. And so I hope you're thinking, or you already wrote down, YTW. And here's a cute little review for everybody out there, because we did need a set of tick marks on that for the congruent triangles. Y is 1 congruent to 2. And I know that everybody wrote down vert angles are congruent. That was lesson 2.8. All right. Thank you so much for hanging in there with me on these videos. Hopefully tomorrow is the last day that you ever have to do this. But thanks for hanging in there. There is homework then, and you can open up the new packet and try 3.1. I'll be taking questions on everything next week. So I hope you're doing well. Hope you had a great homecoming weekend. Talk to you soon. Bye.